So first thing is, we're looking at the, always love to say this word, multiplicative. Yeah, go ahead and say that one. Multiplicative. It's always a fun word to say. It kind of rolls off the tongue a little bit. All right, multiplicative identity matrix. Or for short, they just like to call it I. There you go. That way, if you can't say multiplicative identity, you can just say it's the I matrix. Okay, and basically what that one is, when we're talking about determinants and inverses, this is basically this, that the identity matrix, and they're going to put a number at the bottom, so it's going to tell you how big the matrix is going to be. So if it's an I2 matrix, it's a square matrix, and anytime we're doing a multiplicative identity matrix, you're going to have ones on the diagonal going this way, and every other single number is going to be a zero. So I think it was yesterday we talked about the additive identity matrix where you would add zeros to everything to get the same numbers back. Today, it's the multiplicative identity where if you multiply by a certain matrix, you get the same matrix back. All right, if it's an I3 matrix, same thing. You get one on the diagonal going this way, and every other single number would be zero. If it was an I4 matrix, which we're not going to do, you'd put a one here, and then you'd have zeros here. You'd have zeros there if you needed an I4 matrix, but we're pretty much going to stop with an I3 matrix. If we go into the fours, it's the same steps, same process. It just gets a lot longer for everything that we're going to do. Okay, now here's what we're doing with this one. Here's where we're getting with everything for all the parts and pieces of this one. If you multiply matrix A times matrix B, or matrix B times matrix A, doesn't matter which one you get for this part. And if those two things equal I, then matrix B is the multiplicative, there's that fun word again, multiplicative, there we go, inverse of A and that's shown by A negative 1. Okay, so if you can take two matrices, multiply them together, and you get an identity matrix, whether it's I2 or I3. Again, it could be I4. We're not going to worry about getting an I4 matrix because that's just the same thing as the other one's just bigger. Then basically one of the matrix is an inverse of the other one. And if something is a matrix inverse, then they're going to say it's shown by A negative 1. Okay, so what we're going to do to start with is we're going to kind of give you the easy version of finding an inverse matrix and show you that basically is this one. So our matrix A, which is going to be 1, 1, 5, 4, and B, which is going to be negative 4, 1, 5, negative 1. Are the inverses. Okay, so they give you two matrices, or two matrices, and they ask you, are these two things inverses? All you're going to do is you're going to basically just multiply those two things together and see what answer you get. Okay, so if we multiply A times B, and again, they're 2 by 2 matrix, so that makes it a little easier. If we multiply A times B and we get this, then the two matrices are going to be inverses. If we get anything other than that identity matrix, then we're not going to do that. Okay, so here's where we're just brushing up on our skills from yesterday. So if we're going to multiply A times B, we're going to do 1, 1 times negative 4, 5. So 1 times -4 is -4. 1 times 5 is 5. -4 times 5 is 1. Okay, so first number is, we're off to a good answer because the first number is 1. If we do the first row times the second column, this number has got to be 0. So we'll just kind of see what happens here. So now we're going to do 1, 1 times these. So that's 1 times 1, which is 1. 1 times -1 is -1. So that is 0. Okay, so far so good. And then we'll do the same thing here. This row times this column. 5 times -4 is -20. 4 times 5 is 20. That one's 0. So if this answer comes out to be 1, then we've got everything we need. So now we'll take that row times this column. So 5 times 1 is 5. 4 times -1 is -4. That one is 1. Okay, so final answer for that one was 1, 0, 0, 1. So it asks, are these two inverses? Then yes, they are. And everybody's going, okay, well, that's not bad. I'm still just doing like we did yesterday. We're still going to multiply some matrices together. And if the answer comes out to be this answer, or if it's a 3 by 3 matrix, if the answer comes out to be this, then the inverse matrices are the matrices then going to be inverses. So that's the first step we've got. Okay, now let me show you one where it wouldn't be inverses of each other. Okay, so for example 2, let's do this. Let's say A is 3, 2, and 5, 4. And B is 2, -1, -5 over 2, and then 2.
That's 5 over 2?
Yeah, -5 over 2. Yeah, throw a fraction at you just so that, you'll get used to seeing them, because you will occasionally see some fractions mixed in. Okay, so again, multiplication. Again, you can do, and the good thing is you can do A times B or you can do B times A. It really doesn't matter, because if they're inverses, they'll cancel each other either way and have it be the same answer. So we're going to do that times that. So we've got 3 times 2 is 6. We've got 2 times -5 over 2.
Would the 2's just cancel?
2's would just cancel. So it's -5. 6 minus 5 is 1. So yeah, so we got 3 times 2 and then plus 2 times -5 over 2. Again, the 2's will cancel. So it's 6 plus -5 or just 6 minus 5. Okay, so first number is 1, so we're good. Go to the second column. We've got 3 times -1, which is -3. We've got 2 times 2, which is 4. That answers 1. So at that point, you can stop, because if that number is not 0, then they're not inverses. So at that point, you can just say, nope, they're not inverses, because that number has to be 0. It's got to be this answer every single time if it's a 2 by 2 matrix. Okay, now what may happen with some of the online homework is it may ask you to find out what A times B is, or they may ask for you to find B times A and then tell me what the inverse, or tell me if they're inverses or not. So they might actually make you fill in the whole bracket here and fill in the matrix. But if they ask you, is it just inverse or not? If it's just yes, no, then you just pick it from there. Okay, so now here's where we get to a little bit of, and again, the first part you're gonna go, okay, this is not bad. So first part, this one should be pretty easy. It's some of this stuff we've got to add to these when we get there. So there's where we're multiplying numbers together to find the inverses. Okay, here's where we get determinants. Okay, so if they ask for determinant, they're going to do DET for short. So anytime you see DET, they're just saying we're going to find the determinant. And basically is this. So we're going to start with a 2 by 2, then we'll show you a 3 by 3. So if matrix A is, and leave a little bit of room on the top here because we're actually going to do some work up here. If matrix A is A, B, C, D, comma, and we'll say this, the determinant of A is you're going to take the exact same matrix that you have here, whatever the numbers are, and you're basically going to do cross products, but you're going to multiply them in the up direction. So you're going to do A times D going this way, and then we're going to do B times C going this way. And you're going to subtract those two numbers.
Wait.
Okay, so you're going to do cross products, but instead of doing the cross products going down, you're going to do your cross products going up. Because so whether you do A times D or D times A, that part doesn't matter. Same thing over here. Whether you do B times C or C times B, it doesn't matter. As long as you multiply these two up here and these two over here, that's the main thing. Okay. Okay, so let me give you one with some numbers here. So let's say that A is 2, 5, negative 4, 8. So let's find the determinant of A. So I guess we'll call this example 1 here. Okay, so again, determinant should be really easy. The main thing is, again, you've got to, when you do your cross products, make sure you multiply up. 8 times 2 is 16. It's always minus, and then negative 4 times 5 would be negative 20. So really it's 16 minus negative 20, 16 plus 20, so that determinant would be 36. Okay, easy enough? Okay, and somebody's saying, what's the trick question? For a 2 by 2 matrix, now ours are square matrices. There's no trick to that one. Just multiply your numbers, you get that. It could be positive, it could be negative, it could be 0. You know, who knows what the answer is, but you'll get some number off that one. Here's the one that's going to be that you're not going to like me very much. I'm just going to go ahead and tell you because you're not going to like me. Spencer's got that look like, what? Okay, if it's a 3 by 3, and I'm not going to make you do, you may have to do one of these because after you do one, then there's no need to making you do like a bunch more of these. If it's a 3 by 3 determinant, again, we're going to start with letters just to make it a little bit easier. So A, B, C, D, E, F, and then G, H. And I know we're never supposed to use I for a variable, but we're going to do it anyway, just because we're in matrices. There are no imaginary numbers with matrices that we're looking at, so don't worry about that part of it. Okay, so if you have a 3 by 3 matrix, here's what you have to do. You have to rewrite this. Go ahead and take the original matrix, the ABC, the DEF, and the GHI. And then what we've got to do, because we're still going to do cross products on this one, you're going to take your original 2 columns over here, and you're going to go ahead and put those first 2 columns and rewrite it there. Now, if you want to kind of keep that box we had it here, you can go ahead and kind of put that there if you want to. You don't necessarily have to, but you can just kind of put that there. Okay, and I should not have put that there. And let me rewrite that here because I'm going to run out of room. So I'm going to put that at the bottom down here. Okay, now here's why you're not going to like me very much. Because when you do your cross products, and then why we had to add these numbers on to the end is that if you do, if we went back to this original and try to do cross products, you can do these three numbers here, and you can do these three numbers here, but you've left out D, B, F, and H. So we're going to add these rows back here so we get to include every single number with this one. So to do determinants on this one, we're going to multiply A, E, and I. And then we're going to get the next diagonal here. We're going to get G, F, and B. Or if you're into some of the Disney movies way back when, I guess it was Disney, the Big Friendly Giant. Wasn't that a movie? Yeah. Wasn't Disney, was it? Probably not. Maybe.
Like in 2016.
Yeah. So Big Friendly Giant. Yeah, there you go. And then you're going to do it one more time for C, D, and H. Okay, and just like up here, we had this one going this way. We've also got to go this way. Then we're going to subtract everything going this direction. So now we're going to have G, E, and C. And then H, F, and A. And then last but not least, IDB. Okay, not very pretty. It's a lot of stuff. And and again, it's not anything hard. It's just keeping up with it to make sure you got it there. So cross products going this way, and then minus all the cross products going that way.
I'm sure you're doing that, but like, what about BB?
What?
What about
Which part?
B and E?
Oh, so we're not going to worry about those because by bringing in those last two columns, we're including every number now. So that basically we got A that repeats twice here. So we're using it once to go this way. We also have to use it once to go that way. So the other ones are just the stuff with they're placeholders basically. If you don't think about it that way. Okay, so let me give you one with numbers because that's just a bunch of letters and that looks terrible. So let's get you on with some numbers and let's see if we can get something figured out here. So.
This is such plain coloring. Look at this. This is a disappointing yearbook to look at.
All right, here we go. So for the matrix.
Okay, we got 20 seconds. Alright, I'm putting away the book now. Well, now my backpack is going to be 10 times heavier than what's before. Yes,
Okay, and again, the direction should just be find the determinant. What we're going to do now, instead of rewriting it again, which is what we wind up doing, we're going to take the original matrix and we're just going to show you again. All we're going to do is we're going to take the first two columns we've got and rewrite them and try to keep the spacing the same. If you keep the spacing the same, it will make it a little bit easier. If you go through this one. So we'll go 1, 2, 5 here, then 0, 4, and then -1. Okay, so we're going cross products. And we'll go with pencil so we can make it see what we're going here. So we're going to do 4 times 3 times 1, which is 12. We're going to do 6 times 5 times 0. And the good thing is with that 0 there, that's a 0, so we don't have to worry about worrying and doing anything. The last one, we'll do -1 times 2 times 3. That would be a -6. Okay, and then go in the other direction. We'll do it in blue. So then we're going to do minus everything going this direction. We're going to try to do it in blue, maybe. There we go. 5 times 4 times 3 is 60. And again, it's going to be minus every single one of these. -1 times 6 times 1 -6. And again, we've got the 0 again here, which means that's going to be a 0. So we've got 12 minus 6, which would make that part out to be 6, minus 60 minus 6 is 54. So then 6 minus 54 is negative 48. Again, that would be our determinant. Okay, and again, not hard, just tedious if you go through those. Okay, now one other thing we're going to add to that one, we're talking about that 3 by 3 matrix. And this pretty much goes for any matrix, whether it's a 2 by 2 or a 3 by 3, any ones that we do. But if you do determinant of a matrix, if any determinant equals 0, the matrix does not have an inverse. Okay, and again, 2 by 2, 3 by 3, it doesn't matter. If you do the determinant of any matrix and it equals 0, then that matrix does not have an inverse. Okay, so we've got determinants. We found out that we multiply a times b. If we multiply a times b and it comes out to be this or this, then we've got the inverse of it. So we got that one. Here's the last thing we're going to throw at you for this part. That we're going to give you a matrix, and then we're going to ask you to find the inverse of that matrix. And that's the part where we're going to tie all those parts and pieces together here. Okay. And we're not going to do 2 by 2s. 3 by 3s goes a little bit farther, so we're not going to worry about that. We're just going to stick with the 2 by 2s. So to find the inverse of, let's just say it's going to be matrix A. And again, we're only going to worry about a 2 by 2 matrix. So to find the inverse of matrix A when A is a 2 by 2 matrix. And let's go ahead and kind of give you this. That A would be, because we'll need this for the next thing we'll do here, A, B, C, D. If that's our 4 numbers that we're looking at here. The inverse of A, which again is A negative 1, how they're going to show that. How that's going to equal is that's going to be 1 over the determinant. So we're going to do our cross products here, find out what that determinant is going to be. And then after you do that, what you're going to do to get the inverse of it, you're going to switch these two numbers. So we're going to put D here and A here. And then we're going to change the sign of these two numbers. But they're going to stay where they are. Okay, so matrix A is this. The inverse of A is, again, you got to find the determinant right of this 1 over that number. You're going to switch these two numbers and then change these two signs. So that's your formula, that's your pattern, that's your whatever you want to call it for actually finding the inverse of a matrix when they only give you that one matrix for here. Okay, so basically the question should look something like this. They're going to ask you to First off, they'll ask you yes or no, does the matrix have an inverse? Or they may ask you to find the determinant based on the value of the determinant, does this thing have an inverse? Something like that. And then if the answer is no, then you're done because there's nothing you can do with it. If the answer is yes, then they're going to go ahead and tell you to then find the inverse of that matrix. Okay, or the question may just say straight up, just find the inverse. They may not even ask, does it have an inverse? They may just say, all right, don't worry about that. Just find the inverse of this one. So in this case, we're going to ask the question because question 1 is going to help us determine what the answer is for question 2 for this part A, B anyway. So we'll go from here. All right, so for example 1, here's our matrix. We're going to go 4, 2, 3, 2. All right, and the steps you're going to do every single time is step 1, you're going to find the determinant. So we're going to take that same matrix we've got here. We're going to do our cross products. But again, we're going to go up when we do our cross products. We got 4 times 2 minus 3 times 2. So 8 minus 6 is 2. Again, anything other than 0 means it does have an inverse. So in this case, does it have an inverse? Yes, this thing does have an inverse. And now we're actually going to find the inverse of it. Okay, so step 1, do your cross products here to find out what the determinant is. Step 2, again, is what we're going to do. To find the a negative 1, that's going to be 1 over the determinant, which in this case is 1 over 2. And that's going to be times, again, we're going to switch these two numbers. And then for these two numbers, we're going to change the signs. We're going to make it a negative and a negative because they're both positive, and then 2 and then 3. So we're switching this diagonal. We're going to change the signs on Swift switch. SWIT8. There we go. There's a C there. What are you talking about? So you're going to switch the diagonal going this way, and you change the plus minus signs of the diagonal going that way. Okay, now with a half, that means you got to take every single number in here and you got to multiply it by half. So that's just a scalar is what that one is. So half of 2 is 1. Half of negative 2 is negative 1. Half of negative 3 is negative 3 over 2. Half of 4 is 2. Okay, and that is the final answer that we're looking for there. And again, the whole thing of what we're doing is if we took this matrix, multiplied by this matrix, in the end, we'd come back and get the ones on this diagonal, and we get zeros everywhere else. Okay, again, not hard, a little tedious, absolutely. Is it the worst thing in the world? Probably not. Is it a little annoying? Yeah, it is.
That's why we have our partners.
All right, let me give you one more of those. And then we got one other little thing that we'll tie that in to show you one of this is like an actual geometry application you can do with it. So, Derek, good question.
So for after I find the determinant, I know it's gonna be 1 to the determinant.
Yep.
For a minus 1.
Yep.
But I see you added the negatives to the 2 and 3. When
Yep.
you said change the plus of the sign.
Yep.
Going this way, it's always gonna be going that way.
Yeah, so you're going to swap these two numbers going this way,
Okay.
and then you change the signs of these two numbers going that way. Okay. All right, one more of those. And again, it's not as it goes once you know what you're doing on those, it goes pretty quick. So it's not like it's a super long one. It's just it's a little tedious. So let's go 2, 5. -4, -10. Actually, we'll do two of these. Sorry, I misspoke here on this one. Okay, so first thing is we got to figure out what the determinant is. So if we've got this one here for determinant, we've got 2 times negative 10, which is negative 20. Actually, we'll do the determinant up here. We've got minus, and then negative 4 times 5. Also negative 20.
0, so we're good.
Yeah, so in that case, determinant is 0, right? And if the determinant equals 0,
There's no inverse.
yep, no inverse. There you go. So if you get 0, it's just that easy because, again, there is no inverse you can get from that one. Okay, now let's take that problem we've got here for example 3. Again, that's where we're, because that one's kind of, wouldn't even say it's a problem because we didn't even do anything with it. We just, found out it was 0 and we're like, oh, there's no inverse. Okay. Let's give you one here where he actually gets something that's not 0. So let's say that's 11 instead of 10. Okay, so if we do our determinant over here, we've got 2 times negative 11, negative 22, minus negative 4 times 5 is negative 20. That's negative 22 plus 20, so that would be negative 2 for the determinant. Okay, and again, to get the inverse of b, we're going to take 1 over this number. Again, we're going to change these two numbers, so we're going to swap them. 11 goes there, 2 goes there. And then for these two numbers, they stay where they are. We're going to change the signs. This is going to be a positive 4. That would be a negative 5. So switch these two numbers, change these two signs. And once you do that, now you got to do distributive property, basically doing scalar multiplication with whatever this is. So in that case, that's negative 11 over negative 2. That's just 11 over 2. Negative 5 over negative 2, that's a 5 over 2. Half of 4, negative 2. Half of 2, negative 1.
And that's the final
Okay, and that's your final answer. Okay, so again, not bad, just a little tedious. You've got to do some memorization. Hate to say that, but some of these things you have to just kind of memorize the steps that you've got to do to get through the part. Okay, and last thing here, this is your real world application. Okay, if you have to find area of a triangle, you can actually use area. You can use a matrix to find the area of a triangle. Especially if it's not a right triangle, this is where you want to do this one. Okay, so finding area of a triangle using a matrix. So the area is going to equal 1/2 the determinant of, let's say if we're doing a matrix A, it's going to be 1/2 of the determinant of the absolute value of matrix A. Okay, so how many, if it's a triangle, how many order pairs are we going to have?
3.
You got 3, right? So you're going to have x1 and y1. You're going to have x2 and y2. You're going to have x3 and y3. So there's your 3 order pairs. And to make it fit so that it's an actual square matrix, you just go back and put a 1 over here as a placeholder. Okay, which means we get to do that thing. We'll get to do all those cross products going like that. So that's where we actually get this one. Okay, so here's what we're gonna do. We're gonna find the area. Last one of the day here. Find the area of the triangle with vertices 1, 3, -3, 0, and 5, 0. Okay, and again, this is for any triangle, especially if it's not a right triangle. If it's some kind of a scalene or a isosceles triangle, if it's not a right triangle, this comes in really handy because, if it's not a right triangle, it's hard to figure out what it's going to be. Okay, so here's our numbers. We're going to just plug them in here. So x1, y1, that is 1, 3, and we'll put the 1. X2 is -3, 0, we'll put the 1. And then we'll go 5, 0, and then put the 1. Okay, and again, for the 3x3 matrix, we're going to take the first two columns we've got here and rewrite those here. So we're going to put a 1 and a 3, -3, 0, and then 5, 0. Okay, and then it's cross products time. The zeros kind of help us out because we got 1 times 0 times 1. Well, that is 0. We got 1 times 3 times 5. That's 15. We've got another 0 going here. We got that. Going this way, we've got a 0 there. Going that way, we've also got another 0. And then finally, at the end, we get something that's not 0. We got 1 times -3 times 3. That's a -9. Okay, so 15 here minus -9 here. That's 15 plus 9, which is 24. Okay, and again, area, that's our determinant. So then area is going to equal half of the absolute value of 24. And again, we'll do the half because if it came out to be a negative, you cannot have a negative area. So we just put the absolute value around it just to make sure half of 24, easy enough. That is 12
Bailey,
units.
you missed a lot. Have fun.
Yeah, good luck.
Good luck, Bailey.
That doesn't look easy, though. She said this looks.
Okay.
No, it's easy.